quadratic equations. And we are trying to graph these quadratic equations. Again, we should know that these are degree 2 equations where our highest exponent on the x variable is 2. So we have the function f of x is equal to ax squared plus bx plus c. And our goal is to figure out all the important details about this graph. Well, to start off with, let me tell you the graph of this looks like a big U. And the name that goes with this U is called a parabola. So this graph is called a parabola. So all degree 2 or all quadratic equations, all of their graphs will look like the big U's or will look like a parabola. There's a couple important details about the parabola. The first thing is the point right here. That point on the parabola is called the vertex. If we can figure out where the vertex is in our parabola, then that gives us the most important detail about the graph. The second most important detail about the graph is to figure out which direction your graph opens. And for college algebra, you only have two choices. Your big U can open up, or your big U can open down. In trig, you'll see your parabola open any direction, but in college algebra, your parabola will only open up or down. And again, both of these have a vertex, which is that point right there. That tells us the basics of the most important details about the graph of quadratic equations. Now let's actually work through the advanced details. A different form that you can have of your equation looks like this. F of x equals a times x minus h quantity squared plus k. Hopefully, this formula reminds you of that circle equation formula that we've seen not too long ago. In the circle equation, the h and the k stand for the center of the circle. In this formula here, when we're talking about degree 2 or parabola, the h and the k is going to stand for the most important point again, and that's going to stand for your vertex. Now I want to point out your signs here the same way that you had with your circle equation. Since this is x minus h, your h will look to be the opposite sign than it originally is. But notice that this is plus k, so your k value will actually stay the same sign. So your h value will look to be the opposite sign, and your k value will look to be the same sign. Then, to figure out whether your parabola opens up, so you have a U or a cup like this, or down, so you have a mountain like this. To figure out whether you have a cup or a mountain, that's going to be determined by your A value. If you have a positive A value, then your parabola opens up, and it will look like this. If you have a negative A value, then your parabola will open down, and it will look like this. So those are the two most important details of any graph of any quadratic equation. And again, let's work through an example to figure out how all of these specifically work. My example is negative 2 times x minus 1 quantity squared plus 8. And I want to compare that to my a times x minus h squared plus k, where h and k will give me my vertex, and my a value will figure out whether my parabola opens up or down. So pause the video and see if you can figure out the answer to part A and B of this example. Okay, our A value is negative. So since our A value is negative, that tells us that this parabola is going to open downward. So that automatically gives us a visual of our graph. So that automatically tells us that we're going to have something that looks like this. Now what we want to do is we want to find this point right here, so we know where to graph this on the rectangular coordinate system. So our vertex comes from H and K. So your H value is the opposite sign that we see it. So it looks like it is a -1, so our H value is going to be +1. And our K value is the exact same sign that you see it, so our K value is 8. So our vertex here is +1 and +8. Now those are the most important things on this parabola, but we actually can come up with more details about it. So let's talk about that. So we want to figure out how to come up with the y-intercept and the x-intercepts of this exact same graph. My function of -2 times x minus 1 squared plus 8. Well, hopefully you remember this from last week's material. To find your y-intercept, you let your x value be 0. And you're going to solve for that equation there. So y is equal to -2 times 0 minus 1 squared plus 8. So -2, this is 0 minus 1 squared. Well, -1 squared gives me +1. -2 times +1 gives me -2. And -2 plus 8 gives me 6. So that tells me my y value is 6, or my y-intercept is the point at 0, 6. Since these parabolas open up or down, you should only have one y-intercept. Now the x-intercepts. Again, hopefully remember, you find the x-intercepts by letting your y value be 0. Now we don't see a y in this equation, but we know that y and f of x are interchangeable. So really we just set 0 equal to this equation here. Now this is a quadratic equation, so you can solve it one of numerous ways. You can factor it, you can use the quadratic formula, you can complete the square. But since I only see one variable, the easiest way to solve this equation is to isolate that variable. So let me move my 8 to the opposite side by subtracting 8. Gives me -8 is equal to -2 times x minus 1 squared. Get rid of your -2 by dividing by it. Gives me 4 is equal to x minus 1 squared. To get rid of the square, you force in a square root. And when you force in a square root, you force in a plus or minus. That gives you positive and -2 is equal to x minus 1. Then to get the x completely isolated, you add 1 to both sides. So you have x is equal to 1 plus or minus 2. Now, since these are pretty or rational answers, you can actually simplify this farther. So the first one is 1 plus 2, or x equals 3, where your first intercept is 3, 0. And the second one is 1 minus 2, which gives you -1, or your second x-intercept is -1, 0. Now remember, your intercepts are points on the graph, so those must be an ordered pair or point form. In most of your parabolas, you're going to have 2 x-intercepts. In some cases, you'll have 1, and in some cases, you'll have none, but I'll talk about that at a later time. So the last thing that we want to do is we want to sketch this graph. Now I've listed all the important information here that we found in the last couple of slides, and so we're going to put all this together and we're going to figure out where our U is on this graph. Let me start with my vertex. It's at 1, 8, so that's my ordered pair here. I have a y-intercept at 0, 6. I have x-intercepts at -1, 0, and at +3, 0. And remember that this graph opens down, so my u is going to look like this, where my top of it is at this point right here. So I've got to hit my top of it at that point there, and I've got to hit every other point along the way. So there is my graph of this quadratic equation. Now this is where I'm going to stop this video, but in the next video I'm going to come back to this example and we're going to need to analyze some things about this graph.